if you did, for instance, 5 factorial, you would be multiplying all the integers from 1 through 5. Right? So here we want to define factorial n that's going to take the n that you're going to use and is going to compute or output here n factorial. So again, we want to fill out the table. And when we're filling out the table, we want to figure out again what should be the relationship between the item and the accumulator, right? So here we're trying to get 5 factorial, right? So we're going to want to multiply all the positive integers from 1 to 5, right? So there are multiple ways of setting this up, but one way to think about this is the item, right, is the number that your accumulator is going to be what you've multiplied so far, right? And your item is going to be like what you need to multiply next, right? So by going with this here, we would say, okay, I know this is 1 here, but we haven't multiplied 1 yet, right? Because the idea of how we're setting up this table is that we still need to multiply what item we're given right here. Okay, so basically what we're saying, this is an empty product, right? We haven't seen any numbers yet, so what do we want to start the accumulator at? So I'll get to that in a moment on why we make this 1. But for now, let's just keep going with this, right? So, okay, so basically I say now I give you 1, right? So what are you going to do? You're going to take this 1 that I gave you and multiply it by 1 to get 1, right? So that's going to be your second accumulator. And then you're going to say, okay, now I'm giving you the number 2. So what do you want to do? You want to take this accumulator of 1, multiply this current number I give you of 2, and then ACC of 3 is going to be 2, right? So now you have this accumulator of 2, right? And then I give you 3. So you're going to say, okay, what's the new accumulator going to be? It's going to be 2 times 3, right? Or 6, right? So the next one, 6 times 4, or 24, right? And finally, 24 times 5, 120. So the point is, if I'm giving you, really just to think about why I was saying, oh, let's just always multiply that next number, right? I mean, this makes sense because if I give you a list of numbers to multiply, right? If I start just giving you numbers one by one, if I give you like 1, you're thinking, okay, 1, right? If I say I want to know what the product of these numbers is, you're just going to keep multiplying whatever number I give you, keeping track of what you've done so far, right? So if I start giving you numbers like 1, you're going to say, okay, 1 right now. If I give you 2, you're saying, okay, 1 times 2, okay, that's 2. If I give you 3, you're saying, okay, 1. Now you're thinking, okay, I have 2, and now I want to multiply 3, so that's 6. And if I give you 4, you're saying, okay, 6 times 4, that's 24, right? And then if you say I give you 5, you say, okay, 24 times 5, that's 120, right? So the point is, all you need to keep track of when you're multiplying numbers is the product of the numbers I've given you so far, and I just give you that next number. You just multiply that number, and you'll have the product of all the numbers I've given you so far, right? So you don't actually say, like, when I'm giving you 4, rather, when I'm giving you 5, if I've previously given you 1, 2, 3, and 4, you're not thinking, okay, let me just, you're already thinking 24. You're not thinking, okay, you know what, let me scrap that 24 and multiply the numbers 1 through 4 again. You already have the product of them, right? So you wouldn't just say, okay, 24, forget about the 24, let me just do 1 times 2 times 3 times 4 times 5, right? All you need to keep track of is that the product that you have so far, the product of those numbers, right? You don't need to keep track of all the individual numbers you've seen. You just need to keep track of what their product is. And then when I give you that next number, you're just going to multiply that next number to get the product of all of those numbers, right? So that's the point here. That's why we're doing this, right? Because if we want to multiply all the numbers or all the integers from 1 through 5, right, it's just the process that I said. We're always just going to be keeping track of this accumulator, which is representing the product of the numbers we've seen so far, and then we multiply that next number that I give you. Okay, so now that you know this, why do we start this at 1? Why do we make the empty product 1? Why not 0? Well, you could see right away the problem. If I made this 0, then if I'm doing the same process of just multiplying the numbers that I'm given here, I say, okay, 0 times 1, I get 0. So my accumulator is 0. And then I say 0 times 2 is 0. And then 0 times 3 is 0. Or why would I not want to start it at 2? Well, I say if I started at 2, then I would say, okay, 2 times 1 is 2. And then I say 2 times 2 is 4. But 4 doesn't represent the product of the integers 1 and 2, right? So we start this at 1 because 1 has the nice property that when I multiply it by any number, I just get back that number. So if the first number I give you is 1, right, then obviously this will stay 1. But if the first number I gave you is 5, then you do 1 times 5 and you get 5, right? And this is really what you want in the first row, or really say this second row here. The second row, you want the product of that one number that I gave you. But if I only give you one number, you want it to be that number, right? So you started at 1 because if I give you 5, right, you multiply 1 by 5, you get 5, which is what you want to have if I've only given you one number. So it's just convenient to make 1 be an empty product, just like it would be 0 if you were doing a sum, because if you're doing a sum, you want to take whatever number I give you, you want it to be that number, same thing, right? So if I say, okay, 5, right? If I say 5 is my first number, you're thinking 5 is the sum. If I give you 2 next, you're thinking, okay, 7, right? But you're thinking that first number, 5, of the sum of the numbers I've given you so far, right? That's what you want it to be. Whatever the first number I give you is, you want it to be that number. So if I started at 0, right, then that's perfect, because if you just do 0 plus 5, you get 5. Right? So the reason we start this at 1, the reason we say that before we've started multiplying numbers, we should just say, okay, this empty product is 1, is precisely because it works out, right? It works out that we could do the same operation each time. So here, if we were multiplying, right, the numbers to get the next one, right, since we want this first row to be whatever that first number that I gave you, we just pick something that when you multiply it, right, will give you back that number. So we use 1 for multiplication, 0 for addition, right, because 0 plus any number is that number. Okay, so once you've filled out this table, you want to figure out what you're putting in for, again, the entries here. And you just go through that same process, right? The starting with ACC of is going to be whatever your starting accumulator is. That's the first row, first column. Your range is going to start at whatever number is your first number here, right? So whether you're trying to take 5 factorial or 10 factorial, you're always starting by multiplying 1. So the range here is going to start with 1. Right? Now notice here we wanted 5 factorial, so to get the ending we actually stopped at 5 this time. So this is like what I said before. Before when we had 5 we stopped with 4, but here when we have 5 we stop with 5, right? And if we had 10 we would stop with 10. So in general here, whatever number I'm taking the factorial of, I'm stopping with that number. But remember, the way range works, you have to go and put in 1 more. So with 5, I'd be putting range 6. With 10, I'd be putting range 11. So in general, it's whatever number you give me, whatever the n is, I'm going to add 1. So this is range 1 to n plus 1 is the second number, and the starting with ACC of is going to be what you have here, right? So starting with ACC of is the first row, first column. The starting range number is the first one, second column, right? The ending one is 1 more than this, right? But again, it's not 6. It's going to be general to whatever problem you're doing, so it's just n plus 1. And then the last thing we have to do, which was filled in the previous problem, is what we do with the accumulator and the item. And this time we are using both to get the next accumulator. So each time what we're doing is we're multiplying the accumulator and the item of that row to get the next accumulator. So this should be ACC times item, or item times ACC. I want to mention that, again, they have to match these variables. So if I called this like foo, right, this would have to be foo times item. And if I put this also num, this would be foo times num, right? So again, the ACC is just going to be your accumulator. It doesn't matter what you call it. It's going to be this column. Item, doesn't matter what you call it. That second input, it's just going to be this column. Okay, so again, I just want to bring out that you could have done this in a different way. So instead of saying that it was the product of the integers less than this item, you could say, oh, I've already accounted for the item you've given me. So 1 is the product of the integers from 1 to 1. And when we get to 2, we should have the product of the integers from 1 to 2. 3, we should have the product of the integers from 1 to 3, etc. And how this will actually change your table is you could see that over here, for instance, when we have 3, if this is 1 times 2 times 3, right, rather than multiplying by 3, we're going to want to multiply by that next number of 4. So rather than over here, this being ACC times item, it would be ACC times item plus 1. The item plus 1 would be in parentheses because we'd always be multiplying by the next row's item. Okay, that would also affect the range. It would still start at 1, right? But then here, if when we had 4, this represented 1 times 2 times 3 times 4, right? Then we would just be multiplying one more time to get 5. We would be multiplying this by the num plus 1 or the 4 plus 1 to get 5. So this would actually tell us that rather than ending with num plus 1, right, we wanted to, or rather than ending with n plus 1, we really want to end with n, right? Again, because we would make our last row 4, right? So range should be one more than that for the ending number. That should be 5. So we would literally be stopping at n instead of n plus 1, right? And the starting accumulator here would happen to be the same because we would still be starting the accumulator at 1, right? The product of the integers from 1 to 1 would be 1. So I just wanted to point out that you could set up the table in a different way, right? Okay, so yeah, so that basically fills out all of these, the A, B, and C here, right? Okay, and finally, this was just, again, what we have, what we're doing each time, so, or what the relationship, sorry, is between the columns. So every single time we saw that ACC is the product of the items from, can't see it here, but 1, right? So we have to see the relationship between the every row. It's the product of the integers from 1 to, so we have, again, can't see all the items. Maybe I'll do that so you can. You can't, what was I going to say? So you can't have, you want to make something that's always true here. So it's not going to be 1 to n, right? Because that's not the relationship between these two columns always, right? So when we had 2, it was the product of the integers less than 2, right? It was just 1. Product of the positive integers less than 2. And 3, we had already multiplied 1 and 2, right? And 4, we had always already multiplied 1, 2, and 3. So in general, it was the product of the accumulator was always the product of the positive integers less than this number. So if it's less than item, right, it should be 1 to item minus 1, right? So you could see that when we're at 2, we have the product of the integers from 1 to 2 minus 1 or 1 to 1. 3, it would be 1 to 3 minus 1 or 1 to 2, right? 4, we would have 1 to 4 minus 1 or 1 to 3, right? That's the product of the positive integers less than 4. 5, again, 1 to 5 minus 1 or the product of the positive integers from 1 to 4, right? So that's what the answer is here. Again, things like n plus 1, n minus 1, it can't be correct because that would mean it never changes, right? So if we did like 1 to n minus 1, that would just be you're saying you're doing n stays fixed. That's your initial input at 5 in this example. So you're saying, oh, all of these are just 1 to the product of the integers from 1 to 5 minus 1 or 1 to 4, right? That would mean these rows are all the same. So that wouldn't be correct. Okay, so hopefully that gives you some information on how to set up the table, and yeah, that's about all for today.